stopped by putting a bandpass filter in front of the receiver or receivers, as the case will soon be. And also the existing repeater controller is the old serial port chipset that it's using is becoming a problem interfacing with newer equipment. So I put forth a proposal to the repeater committee of replacing the RLC club repeater controller with an RCOM RC210 repeater controller with a port expander. And the RC210, there are literally probably at this point tens of thousands of them in service around the world, and support is second to none. They're very responsive, and best of all, they use modern technology. So we'll get an echo test that actually works, for one thing. We'll get Windows programming software to actually be able to program the controller without having to read assembly language, essentially. And it'll have real human speech, not a synthesized 1980s sounding voice. And the firmware is flash upgradable, so we can do that either on site or remotely, whereas with the RLC, you have to actually change the chip out, which is not ideal. And the accessories for the RC210 are better than for the RLC controller. So that's basically all I have to say. If anyone has any questions, they can let me know.
Actually, I've got a comment. I'm a test company for RCOM, and we have 7 of them running here. And that's a great controller. You won't find a better one.
Yep, that's what I've been thinking. And eventually he hopes to have one with even more ports, so we can have the port expander just go away eventually and have the bigger controller, so we have full control over all 5 or 6 ports that we'd be using.
That's correct. We helped him develop a new port expander that is 3 half duplex ports for All-Star, Echolink, and those kind of connections, and 3 repeaters at the same time. And that is available right now. They just introduced it this week.
Yep, that is definitely the plan.
You can't go wrong.
Good. We'll call you if we have a problem.
Yep, please feel free. I work with them every day, and I can tell you how to upgrade firmware. I can tell you how to do the whole thing. And if you want to see one, I got them sitting right in the other room here, so no problem.
Yep, they're outstanding controllers. We've got a whole bunch of them. Our entire Skywarn system down here in Georgia uses them exclusively on their repeaters. And there's we have a linked repeater system down in South Georgia called the Peach State Intertie, and they all use the RCOM controllers exclusively.
Good decision.
Well, that's all I have.
Okay, Stephen, thanks. As always, you and Jeff are doing some great work, and we know you'll get things back in service, get it back up to where it needs to be. All right. We don't have a camera on the room this evening, though. The cameras are missing from the room, so unfortunately, you don't get to see our smiling faces unless we're personally logged in or something like Rob is. I'm going to go ahead and turn it over to Rob and get our tonight's program started off. So go ahead, Rob.
Are you guys hearing him? I'm not hearing anything. Oh, Rob, you are muted.
Okay.
Oh, yeah, there we go.
Okay. Yeah, I'm pleased to announce that our speaker is Jeff Hilliard, AK6OK. And this is going to be a wonderful presentation. I always leave the biography to the speakers because they do a better job than I can. But one thing I do want to say is I had another speaker lined up for this meeting, and he got sick over the weekend, and so he had to cancel. So I looked at my list of speakers who I was going to call in the future, and I had Jeff on there, and I called Jeff on Sunday and said, we got a problem, I lost the speaker. And Jeff was kind enough really kind enough to say, I'll do it. I'll do it for you on Thursday. So I want to thank you for that. Thanks for getting me out of a bind.
No
And
problem.
again, this should be a great presentation. So I'm just going to, without further ado, since we're already running behind, turn it over to you, Jeff.
Thank you very much, Rob. And listen, what's really important here is that you guys stop me and ask questions. That is like a big deal to me. And this is a little difficult because I normally am standing in front of 75 guys doing this, and on Zoom, it's a little different deal. So if you take a peek here, I've got a Rigol DSA 1038. Can you guys see that okay? That's a spectrum analyzer. That's what we're going to be talking about tonight a little bit. And do any of you guys have spectrum analyzers? Nobody? Huh, okay. You're going to like this. This is kind of cool. So I'm gonna kind of walk through basically what a spectrum analyzer does. And you see I've got a UHF antenna on here right now. You can pretty much use any kind of an antenna you want. I'm going into the RF input. And a spectrum analyzer has an RF input and it has a generator output. Not all of them have the tracking generator. That's what this is called right here, is a tracking generator output. What that means is that when it's receiving a signal, and this is if you look, I'm on 442.525, and I don't know if you can see that. And if I key up my DMR radio, I've got a little Motorola job right here. You see it right there, and you also see it pulsing. Does anybody know what that is? That's not a solid carrier. I'm holding the carrier down. I'll answer it for you. That's DMR. DMR is a little different than a solid carrier. It transmits on 2 time slots. It transmits on time slot 1, stops, transmits on time slot 1 again, and you can actually have 2 concurrent connections at the same time through the same repeater. And so that's what you're seeing here. You're seeing a transmit on time slot 1. Every time that happens, if somebody were transmitting on time slot 2, it would be between these pulses is where they would talk. It's a pretty interesting concept. But if I go to a frequency, I'm going to change and go to a standard UHF repeater frequency here. I'm going to go to 444.900. So you'll see what it says frequency right here, span, and amplitude. Every spectrum analyzer made has those 3 buttons on it. So if I go to frequency and I just punch in 449.9 megahertz, and I key up this thing, you're going to see a solid carrier right there. Okay, now let me do something here. Let me go to amplitude, and I'm going to say auto scale that thing. There you go. It actually adjusts it so it's in the center of the screen for you. So as I key up, you can see the carrier. If I go to span here, you guys, you'll see I'm looking at 100 megahertz wide, starting right here and going to here. I'm going to change the span to 10 megahertz. Let's key it up again. So there's 10 megahertz. Let's go to 1 megahertz. And this is exactly how you can tell how wide the signal is and if it's on frequency. I'm going to go down. That's 1 megahertz. Let's go down to 500 kilohertz. You'll see it gets a little wider, but you can see it's dead on frequency. That's Motorola for you. They're on target. So, okay. So anybody have any questions so far? Jump in if you do here. Now I'm going to try something else here. There is the primary frequency, and I've got it again on 449.5. I am going to go to double that frequency. Let's call it 500 megs. there's 500 megs. You know what? So let me check something here. The span is 100. Let's make a span 300 megs. Let me check, see what I see. So there's the primary. I don't see anything out there, which is kind of cool. So at 500 megs, no signal there. So it's very, very clean on the output. You've heard about harmonics, and harmonics is double and triple the primary frequency. And so that's what you use a spectrum analyzer for, to check to find out if you have any spurious signals out here, usually to the right. So you got your primary frequency, and as you go to the right, you're going to see whether you have any spurs hanging out that way. Now, you guys were talking about a bandpass filter. Crazy enough, I got one right there. That is a UHF bandpass filter. And it's simply a filter that, well, I'm going to show it to you. Let's do this. I'm going to take this antenna off. We're going to use the tracking generator now. And I hope you guys have questions after this, unless you're just soaking this up good. But all right. So this is the generator output. This is going right into one side of this filter, okay? And then this goes into the input. So we're going to be putting, all right, now here's what you see right here. It's pretty interesting. So I'm going to say, let's make the frequency of this. This is a UHF. It's 440 to 450 megahertz. And so I'm going to say, let's make the frequency 445 megahertz. What do you guys see? Pretty interesting, huh? It is letting that through, and it's knocking those frequencies out. It's exactly when he was talking about interference. It's exactly what he was talking about. I'm going to push the span button, and let's widen this thing out a little bit. Okay. So we got a span of 60 megahertz. Now I'm going to push something called a marker. You see that little number 1? Can you guys see that moving right there? Yeah. Okay, so that's at 438 megahertz. That's called the skirt. That's where it starts to drop. So anything below that, it's going to take out. And this is where you have co-channel repeaters that are hanging out in the commercial band. This is how you stop them from causing your receiver trouble. You put a bandpass filter in, and if it's a frequency that's down in here someplace, it's going to be down, what, 45 dB right here. And right here, it's down, what is it, about 2. So depending on what frequency you're on, I'm going to move this marker over, and you can see the frequency change right there. Right here, where it starts to drop, is 450. So this thing's pretty accurate. You can see that it's letting through that right there, and it's dropping off on both sides. And so when you talk about a bandpass filter, that's exactly what this thing does. That's the beauty of a bandpass filter. It's exactly what that thing does. Now, if I were to take this out of here, and I'm just going to put a jumper from one side to the other. So let's just take this and go from the generator right in to the spectrum analyzer input. All right. And I screw that in. You're going to see that it goes, it's just a flat line. It's a flat line because whatever it sees coming out and coming back in, there's no attenuation. There's a little bit there, but there's no attenuation there. Good solid signal all the way across. But when you run,
I've got a question.
sure, go ahead.
You ranges the tracker sweeping.
Say it again. I'm sorry.
The tracker, what frequency range is it sweeping through?
Okay, it's specified by the span. The span currently is 60 megs. You can change that any way you want. You can change that a couple of ways. One way you can change it is with the dial right here, or you can actually type it in. I want to make it 100 megs wide. I want to make it 50 megs, whatever you want to make it. It does. And so let's put this guy back in here so you can see that. But that's a great question. What is the span? The span is wherever you set it. Let's get this thing back in there. So if you push, you see currently the span, I don't know if you can read that. It says 60 megahertz. Let me get a little bit closer. So 60 megahertz is the span right now. Push the span button and move it. There's 68 megahertz. If I want to make it wider, I'm sorry. There we go. There's 30 megahertz wide. And then you've got your little number 1 marker right there. When I push marker and I can move it, I can find out exactly what frequencies it's starting to roll off right there. You guys see that okay? So,
Yes.
so you can change the span to whatever you want.
So that you have the base frequency, which is in the middle, and then the span is on either side.
That's correct. So the base frequency, push that frequency button. The center frequency I have set at 445. Now, push that frequency button. I can type in a different frequency or turn the dial and see what it does. It moves it. So the center frequency is changing. And so that's telling you is that, yes, the center of this thing is at 445. And this is a 440 to 450 bandpass filter. So it's doing exactly what it's supposed to do. And then amplitude I can change right here. I can go up or down. And if you want to do a little calibration here, you can see the reference level difference and all that. So that it has an auto scale as well. What I normally do is I'll get it to where I can see the outside edges here like that. You can see this thing is pretty sharp. So in this range, the 440 to 450, it's doing what it's supposed to do, but it's knocking out stuff above it and below it. Does that make sense? Now I'm going to show you a piece of magic. This is really cool stuff. Have you guys ever heard of a return loss bridge? Most hams, no, they've heard of it. They don't know what it does. So I'm going to unhook these 2 pieces of coax here. Let's get this guy out of the way. Here's what's called a return loss bridge right here. So it has an input. It has a generator output. So I'm going to take the tracking generator output right here, and I'm going to put it in the output side of this guy. I'm going to unhook right here. I have an antenna right here. It's a UHF. I think it's a, what do you call that antenna? I think it's called an elk antenna. It's a dual band antenna. I got on a little piece of post here. I'll show that to you in a second. So I got RF in and RF out. Tracking generator is running. Make sure it's running. It is. And let me put the frequency at 145 megahertz. And I'm going to put the span at, I don't know, call it 50. There you go. Okay. And the amplitude, we're going to move our reference level up here. I'll stick it right there. Here, let's make it right there. All right. So you can see it's a flat line right there. Okay. Now, right here, this piece of coax I got sitting right here is hooked to that elk antenna, which is right here in the room. I'm going to hook it up. I want to show you something kind of crazy. Now, that looks pretty doggone weird, doesn't it? Take a look at that. Now, the center frequency I'm on is 145. Let's move this 143.25. What that's telling you is the exact resonant frequency of that antenna, even though your SWR might look awesome. It doesn't necessarily resonate where it says it is. So if you look at dual band antennas on your car, for example, one problem is that sometimes they do trickery inside the coil. They'll put a capacitor, an inductor, or whatever to make it broadband and banded and look okay with your SWR to the radio. The radio's happy. However, if you look at it with a return loss bridge and a spectrum analyzer, you're going to look at the truth. Right here, when I plug this in, so you can see this right here. If I unplug this, you're going to see this go to a straight line again. Okay, that's because The signal that's going in is coming right back out because there's nothing on the device under test port right here. What this port is, and the easiest way I can explain this, you guys, when I introduce an antenna, whatever the resonant frequency is, which is right there, let's just say it this way, even though it's not quite the truth, it sucks that signal out of the path. And it's showing you right there where it is resonant. So that antenna is actually resonating right there, right now, and pull the signal out of this path, and I'm looking at it. Now, see, there's a couple of other spots. It's sort of resonating also at 151 and 156. And so you got to see what it is. Now, if we make the span wider, like, let's widen this out a little bit. Go back to the frequency. All right. So now you can see 143.3 is where it sees the exact frequency of this thing is. If I start moving out, so the center line, there's 144 right here. Does that cause you guys any grief right there? I mean, it's not resonating at 144, it's resonating at 143. So the bottom line is when you're using a spectrum analyzer, now this thing is not up on a tower. It's got stuff next to it. I'm going to go over there. I'm actually going to go over there and get my hand near it. And you should, I don't know if I can see that while I'm doing this. But if I get my hand near this thing, did you see anything change? So it has to do with what's around it. Oh, it did change. So it has to do with what's around it. If you take a vertical antenna, like a dual band a mobile antenna, and check it like this, if you just lay it on the table, it's going to be way off frequency, but you put it on the trunk of your car and it probably will drop right into place where it belongs. If you have any metal around it anywhere, it's going to change it as well. So ideally what you want to do is you want to get the antenna installed wherever it's going to be and test it at that point. And get away from the antenna, get 19 inches plus away from the antenna so you're not affecting it. But you can see what happens on a spectrum analyzer. If you put your hands anywhere near it, you'll see what the effect is. It really affects the antenna. Okay, what questions?
What device is that you're using?
What's that?
The device that you have hooked up that's doing that.
This is it right here. You're talking about the return loss bridge?
Yeah.
This guy, it's called an Eagle made in Wichita, and it is it's a return loss bridge. This is fairly common. A lot of radio shops use these guys, and it simply has an input, an output, and a place to put the device under test, which is an antenna. Now, let's try something different here. I'm going to hook up a rubber duck. You're going to love this. I had this demonstration the other day, and a lot of guys just went, "Are you kidding me?" All right, so here's a rubber duck, and the resonant frequency of this guy is up in the UHF band. I don't know exactly where it is. Well, let's just do that. Let's go change the frequency to 450 megahertz, and I don't know how far. Let's see. Go to the amplitude. A sad connection. Oh, it's being affected by everything. Hang on a minute. Well, you can see my hand is. Let me look at the span. What do we? Oh, hang on. I got to get the span way out here. Just moving my hand near it affects the frequency drastically. I can't remember what frequency this is supposed to be. Let me move up. Yeah. 100 megs. Yeah. So not a great demonstration. We did take some ham antennas, and I was actually pretty surprised at how close they were. Some of the handheld antennas and stuff. So, but if you put them near on a radio, it actually acts different than if you put it on the device under test port here. So, but it's a really fascinating subject to talk about. What frequency then antennas do they really resonate on? So that's what this is. This is a return loss bridge, and that's its primary use. And you're looking at SWR and you're looking at resonant frequencies, and that's what happens when you hook an antenna to it. Now, if you were to hook a dummy load to this, that's going to be a flat line. So if you hook a dummy load to it, you'll get a flat line. If you hook an antenna like this elk antenna out here, and again, got to change the frequency back to 145. I don't know where those up antennas go. I'm not sure. Let me get the amplitude right. And there you go. And get the span out a little bit, widen this guy out. So just about every spectrum analyzer you're going to find runs the same way. You have the same controls. The HPs, Agilents, all of them have frequency, span, and amplitude. These guys right here. And then the tracking generator. So when you buy one, if you're looking for a spectrum analyzer used, make sure it has a tracking generator output. If it has only one RF connector on it, it's a straight spectrum analyzer. If it has two, it's got a tracking generator. So that's something you want to look for, and make sure it's got two of them if you want to do this kind of measurement. So that's about all I got for you guys right at the moment. Unless you have some questions, I'd love to answer any questions you guys might have. No questions.
I got one, or a comment, I guess. Every
Who's
time
got
I've
one?
looked at a spectrum analyzer in the past, they've been way out of budget. While you were talking, I looked on the internet a bit about it, and I see they're discontinued and list price $3,000. That's quite a bit of test equipment. I would
Well,
love to have one.
that's not completely true. You can buy a brand new Siglent or Rigol for $1,000. And that is one that goes up to a gig, which most of us will never need. So the prices have really dropped. Used, you'll see these at $600 and $700. This is a 3 gig version. I've never used it over a gig. I've never used it over 450, as a matter of fact. So this is more than most people need. But if you want one that just goes to a gig, you can get a brand new one for less than $1,000 now. They've come
Good
with
information.
Yeah. Don't buy a 3 gigger if you don't need it. If you're not gonna be doing this stuff up there, it's crazy to go out and pay that kind of money. Just don't do it. So buy what you need. Any other questions? I was gonna cover oscilloscopes. May want to do that at a different time. We got started really late, but oscilloscopes are interesting too. They're a little simpler than a spectrum analyzer. Is there anything else that I didn't cover that you may want to know about? We went through the DMR discussion a little bit. If you want to know a little bit more about DMR, I can cover that too. Do you guys have DMR repeaters out there?
Yes. Yeah, our club has one.
Okay.
We do.
They're really popular out here.
Yeah.
So. Okay, Rob, no other questions? Are we good?
Yeah, we got a question. Stand by.
Yes.
How do you use the spectrum analyzer to test HF antennas?
Exactly the same way that we're doing it right here. You can use a return loss bridge. And instead of using a UHF antenna, put an HF antenna on it, and you're going to get the same exact results. Now, if you want to find out what the actual SWR is, use an SWR bridge. There's a way to calculate by looking at this waveform, for example. There's a way to calculate what the SWR is as well. Here, let me get back over there. There's certainly a way to find out. There's the resonant frequency, but you're going to see the same thing on an HF radio. The concept is exactly the same. So does that make sense? It's the same on HF as it on VHF. Just make sure that your analyzer covers the HF band, which it will. Most of them, this one starts at 9 kilohertz and works its way up to 3 gigahertz. Just got to make sure that it covers the band you're on that you want to look at. But the concept is exactly the same no matter where you are. There we go. By the way, some of you might have been wondering, but if you have a TS940, I'm the guy that designed the upgrade kit for the TS940, the power supply upgrade kit. That's a great old radio, and we sell a ton of them. So that's one of my expertises, is that 940 and 930 radio from way back in the 70s. So how about that? So Rob, did I bail you out? You're muted. Rob.
One more question.
Yeah.
What about the inexpensive, like the Nano VNA supposedly has got some spectrum analyzer software for it, or, you know, for the super low and spec ends? How do those?
You know,
Oh,
they
go.
work surprisingly well for $50. And you're not going to get the accuracy you're going to get out of this. Yeah, I mean, they're not made as well as these are. These have got filtering and everything in them. But you know what? For the $50, they're worth having one, because you can do exactly what I'm doing right here with one. I don't believe, I'm not sure, do they have a tracking generator built in? I don't think they do. I think the Nano does not, as far as I know. But great deal.
Yeah, because the VNA's got multiple ports on it.
Maybe it does. Yeah. I mean, if you've got a tracking, you know what? I think you might actually. I don't use, since I've got this, I just don't have a need for that. But yeah, I mean, especially if they got a tracking generator, you can tune duplexers. By the way, I do tune duplexers with this. If you want me to run out and grab a duplexer, I can show you how we tune them. But we tune duplexers here as well. And same exact concept. You're doing the same exact thing here, just like this bandpass filter, but you tune it for a transmit frequency and a receive frequency. And it's very simple to do, as long as you've got a spectrum analyzer with a tracking generator in it, whether it's a Nano VNA or not, that would work as well. I don't know that I would trust the frequency accuracy of them. I don't have that much experience with them. So you want to make sure that they're on frequency. When you are tuning for the correct frequency on a duplexer, for example, it better be dead on, because if it's not going to work well. Us hams, and I go
pay
back.
people to do that.
What's that?
Oh, we paid people to tune our duplexers.
You need to be doing it yourself. I know, but they're really fun to tune. If you want to see that, I could go run out and grab a duplexer out here if you guys are interested in that. If not, no problem. But it's a very similar concept, how you do it. So whatever you want to do.
You want to go into the oscilloscopes?
Yeah, I can. I didn't set up for oscilloscopes, but I've got one out here I could plug in real quick if you guys want to kind of see how that works. You want me to grab one?
Yeah, please.
I'll grab a scope. Hang on a second, guys. I will be right back. Anybody else got a question before I take this out?
As we say here in the South, you have flung a craven on me.
What does that mean?
Means I want one of those.
You know what? Normally when I finish a full-blown demo on these, a lot of guys come up and complain because, yeah, they got that burden in their wallet too, going, man, I want one of those. So, you know, I think I should get to the point where I give one away at every time I do a class. That would attract a lot of people. All right, I'll be right back, you guys. Hang on. If you want to talk, keep going.
Thanks. Where are we here? There's a big delay on here. That was interesting. Yeah, maybe the club ought to buy one and lend it to the members. Yeah.
I think we did. Rob, I get a message here that says that your network bandwidth is low.
All right, let me try something. And If it doesn't work, I'll see you tomorrow.
Yeah, so there we go. All right, let me unhook a few things here. Yeah, sorry I wasn't 100% prepared here with the scope. We'll get one hooked up. Okay. There we go. And as you guys have probably figured out by now, scopes have gotten really cheap. Let me get my camera back on here. All right. So oscilloscopes have gotten awfully cheap lately. Let me get this a little bit closer. There you go. Can you guys see that okay? And there we go. Let me click this on right there. All right. Let me get this taken care of here. One sec. Oh man. Let me couple that with AC. There we go. Okay. And let me get the trigger going. All right. Let's look at this. Hang on, the trigger I don't like. There we go. Okay. So I would assume some of you guys have scopes. By the way, this scope is $200, brand new. Scopes have really dropped in price. This thing's made in China by Seedless. Do I like Chinese equipment? Not at all, but doggone it works. You know, I hate to tell you, but it does. You can buy a Hewlett Packard for one heck of a lot more money, but the accuracy of these things is pretty doggone good. So right now, here's a scope probe that's tied into channel 1 right here. And if you look, here's the vertical controls for channel 1 and 2. What the vertical does is change, the memory is turned on, this thing, I need to turn that off. Hold on one sec here. Oh, here it is right there, turn that off. Sorry, guys. One sec. It's going to give me trouble here. There we go. That's what I want to see. Okay, there we are. Okay, so this is a square wave, and the square wave is actually coming out at 1 kilohertz right here, out of this spot right here on the scope. So I have this hooked up here, and then there's a ground below it. So all I'm looking at is a square wave at 1 kilohertz. And this control right here is the vertical control. So if I want to make it 2 volts per division, I can make it higher or lower. So when you look at the screen on an oscilloscope, vertical is voltage, the horizontal is time. So voltage is up and down. That's the y-axis. The x-axis is time. And so if I want to see these closer together, I can do that. That's 1 millisecond per division. So right there is 500 microseconds per division. So each one of these pulses is 500 microseconds. And you'll see right there, it says that's 1 kilohertz. So this is a pretty smart scope in the fact that when you're looking at a signal, it tells you what the frequency is. This one goes up to 200 megahertz. They've got scopes that go clear to a gig. And did somebody have a question? Some scopes will go clear to a gig, and you can actually see UHF and VHF frequencies on here when you key up. So, and then you have coupling right here. Coupling is, do you want it DC coupled? And DC coupled means that when you're looking at DC coupling, it tells you if there's a voltage riding on the signal also. So if you have 3 volts on there and you have the waveform above that 3 volts, that's DC coupled, it'll actually measure it for you. Now, I can move, let me see here. Yeah, interesting. Let me see how this is coupled right here. I'm going to shoot myself in the foot, I know. Yeah, I'm not sure how this is coupled. So, and then you have triggering also. I'm not going to get into that stuff. I think that's, I can get into that in another time. Yeah, there's normal right there. So now I broke it. There we go. Come on, set it up. And see, it's out of sync right now because it's not being triggered properly. And oh, brother. Hang on 1 second. Okay, 1 minute. Put that on DC. And the source is channel 1. So it says the source is channel 1, which is what I'm plugged into. That's where the triggering comes from. Let me go to auto setup. Let me see what it does here. That's always a great button for everybody. Auto setup. There it goes. Okay. So now here's one of the cool things the scope does. I used to work with genetic fusion. And boy, here's a piece of trivia I don't talk about much, but I was involved in the development of the seedless watermelon. Okay, so I was a genetics engineer. We did some crazy stuff back then, and I'm not proud of all of it because we also made tobacco that was Roundup proof. You could crop dust a crop with tobacco and it would kill everything except the tobacco plants. Now, I don't know what it did to the people that smoked it. We also made square tomatoes. Now, the technology that I used to do that is we were switching 500 volts at 500 amps for a very, very short time. But the rise time, when we turned that MOSFET on, we had 3 MOSFETs in parallel, and they were 90 amps each. Okay, so to do this, so you can't use a relay, it would blow the thing up. So we use these 90 amp MOSFETs. If you look at this is ground right here, you see this comes up here, and there is a time from when it gets from here to here. I'm going to try to explain this to you because it's really critical stuff. If you look at that, that turn on time can kill a MOSFET, and I'll tell you why. Imagine that we're turning it on and it takes 100 nanoseconds to turn on, and you're drawing 500 amps through 3 MOSFETs. If it goes too slow, the MOSFET will explode because it's not turning on fast enough. We actually had to use driver chips that had a rise time of 1/10 of a nanosecond so that we wouldn't blow the MOSFETs up. So when we look at something like this is the value of a good scope. I can look at this rise time and go, wow. You can see the rise time of this is crazy, right? That is a long time because we're at 200 nanoseconds per division. And you go 2, 4, 6, 8, 10, 12, 14, 16, 18. Yeah, 18 times 200. You're going to blow a MOSFET up. So when you're working with super fast signals, this is one way you can find out. So it's kind of interesting. This is not made for driving MOSFETs. I'm just telling you about what we use a good scope for and why that's so important. So anyway, and you have 2 channels. You can turn on the second channel and it gives you a different color. So I can put a second signal in here. And the purple one is channel 2 and the yellow one is channel 1. It has display persistence, which means it will leave it on the screen if you want. I hate turning this on because it's hard to turn off. Let's see. So, and you can store these waveforms and compare them with another waveform that you lay over the top of it. So look, this $200 scope has a lot of horsepower, right? Compared to all the old Tektronix and stuff that we used to try to get our hands on for as cheap as possible at a swap meet, do yourself a favor and go buy a cheap scope for $200 and you got more than you could ever buy 5 years ago. It's really, really changed. And then we have measurement functions here as well. And so that we, just like the cursor that we had, here, I'll go back here again. Just like the cursor that we had on the spectrum analyzer, you have the same kind of cursors on this. And I got, let me check something here. I am not the guy. Oh, hang on a second. Well, anyway, you can put start and end cursors on here and it will read out up here and tell you how far those are apart, what the frequency is, etc. So does that make sense? I'm not great at oscilloscopes, guys. I do a lot better on spectrum analyzers, but that gives you the basics of an oscilloscope. So again, you're looking at voltage on this axis, on the y-axis, and you're looking at time on the x-axis. If I want to look at more than one of these at a time, then change the speed. We're going, we were originally here at what, 10 microseconds per division. Let's go to 20, 30, 100, 200. Now you can see multiple pulses at the same time on the same screen. In the same way that you could look at a 60 cycle signal if you wanted to, right? And so you can look at whatever kind of a signal you want. And there's a print function in here too. You can hook this up to a printer and print the screen. It has a USB port. You can actually write this to a USB stick, put it on your computer and bring it up and print it out, keep it, do whatever you want with it. So I hope that's a little more informative about a scope here about, don't be afraid of these things. These things are cheap and they work fantastic and they are brand new. You can buy these used. I think I paid $150 for this thing used. So not that expensive. Go sell one of your cheapy radios and buy yourself a scope. Might learn something. Go ahead, Rob.
Tried to buy an HP at the Hamfest, and I came back with the money too late. It was it the no, it was a Tektronix 456, I think, that the one that everybody had.
The CRT.
Yeah, the classic Tektronix.
Yeah. You know what though, Rob? Those are really cool to have, and they're big. This thing weighs 3 pounds, and what's that 465 weigh? That thing is a dog, man. They're big. I'm getting older. I'm 68, and I don't like picking up those big old hunks of metal anymore. But I got to tell you that this scope has 10 times the horsepower that that does, right? With persistence of the screen, all the measurement functions, you can't do that with one of those old scopes. So some guys are into this vintage equipment, and I get it. I've been in it myself, but the older I get, the smarter I get. I'm not hanging on to that stuff anymore. I'm getting rid of it. So I have to use this in our business too. When I'm building power supply systems, it's really important for me to be able to go look at noise, because that'll drive radios nuts. You got to make sure there's no noise in the supplies. And there's all kinds of measurements you can make with a scope to check that. One of the measurements that we make, if you have for example, a 28 volt signal that you're looking at, 28 volt power supply, which simply is a flat line, but on that flat line at the very top, if you have noise there on the power supply, you can actually amplify that with a scope and go look at 100 millivolts of that signal and see what that is. What is that garbage up there? It may be that you need a high frequency capacitor to suck that out. And that's why you see different capacitances on the output of power supplies, because the great big caps like 500 microfarad will take out that low frequency stuff. But if you see high frequency junk rolling around, especially on a switcher, you may have to put other caps in there as well. Very common on our power supplies. We use 2 or 3 caps in parallel, but they're different values to suck out all these different signals that come out of that thing. And so you want it to be good and clean. How do you check it? Is with an oscilloscope. It's exactly how you do it. Your mic's off, Rob.
I got one question.
Go ahead.
Go ahead. I've got an old Tektronix 465 from back in the 70s that I used to use then. And I still got it. And I got a Tektronix TDS 210, I think it is, that I bought new about 20 years ago. Right now, neither one of them work. I think the TDS 210 needs a backlight in it. But I've seen advertised in some of these magazines something called a picoscope, which I think is a little box you plug into a computer. I wonder if you comment on that, if that's worth an investment, or should I buy something like what you're talking about?
Absolutely, they work great. And just got to make sure you get good software with it. You know, some of the Chinese stuff that you get, you can't even hardly read the manual because it's such poor English. And so you just want to make sure you get a good manual with it. If you can read the manual ahead of time, just make sure you can tell what it says. And then it comes with software to run with your Mac or your PC. But as far as performance, yeah, they're great. They are great.
Well, those things run on Linux.
Yeah, they do. Right. And some of it's open source. If you're into Linux, you can write your own software too, right? So that's another big plus for sure. So I would not hesitate in doing that. This is much more convenient for me to put on a bench and use by itself. But all of these scopes now have USB ports. They have network ports. When you plug a network into this scope, you go to the IP address and it brings up a picture of the scope on any computer in your office, right? And you go look at it. You can copy it, you can save waveforms, you can control the scope. So these scopes are now fully controllable by the internet. If you want to go grab a signal off of something that's on a hilltop, you can grab it, store it, change it, do whatever you want. So things have changed a little bit. It's pretty neat stuff. So I wouldn't hesitate in buying one of those, the picoscopes. No, they're great.
Thanks.
Question.
Yes.
Yeah, speaking of those little cheap, inexpensive things, I saw some return loss bridges on the internet, I think from Alibaba, I guess like down to $16. Are they any good to be used? I'm suspect because they didn't come in metal enclosures.
No, they're not good, and don't waste your money. In fact, I stay away from Alibaba, although the stuff's pretty attractive there. But I go to a swap, and you'll find them out there. You don't need that particular one. There's a bunch of different ones out there, and you can get them. I've seen them as low as $3 and $4 at a swap. A lot of the hams don't know what it is. I actually got one today. Let me show you something. Hang on, I'm gonna grab something here. Where is that thing? Hang on. Okay, here's what's called a coaxial directional coupler, okay? Well, there you go. That's exactly the same thing as a return loss bridge. Okay, these are made by Narda. This can be found at a swap for $5, and most of the times the guys that are selling them don't know what they are. That is a high-end directional coupler. Now, here's a caution. This particular one is 0.125 to 250 to 0.250 gigs. This is a 125 meg to 250 meg. I don't know what that was. So 125 to 250 megahertz. Okay, so make sure that you got one that covers the band that you need. Now that little eagle that I just showed you goes from 0 to a gig. That is why I have that particular one. You can probably get those for about $100 used. So no, don't buy on Alibaba. Don't buy anything with you got to have a cover on it of some kind. It's got to be in a metal enclosure. And you can see how stout this thing is. Just look at the screws in this. That's built like a tank. So you want to make sure you get something decent. So, and make sure you have a spectrum analyzer with a tracking generator in it. Really important. Now, you can tune duplexers and stuff without a tracking generator, but you have to have a generator to generate a signal and use the spectrum analyzer to peak it. You can do that, but if you have an analyzer that has a tracking generator, it's all built in the same box. It's really easy to use. So I highly recommend you do that if you have the time, if you have the resources to do it. Okay.
Thank you.
Sure. What else? Anybody else have a question, comment about either the oscilloscope or the spectrum analyzer? Nothing. Did I cover it?
Yeah, just a comment that you had said something at the beginning that you were considering moving to Tennessee. I would ask that you consider the Atlanta area because we could use you around here.
You know, I'm always available, you guys. And thank you. We've also looked at North Carolina as well, and Boise, which is quickly fading away for us, but they're getting a little too liberal out there in Boise area. But I do classes on all kinds of stuff, on building antennas, filters, duplexers, power supplies, all kinds of things. And I'm in a lot of the Hamfests and do, different things. And so if you need me for any other type of a class and somebody's got something they want us to demonstrate, from DMR and programming your anytone radio or whatever it happens to be, we kind of do it all here. So I'm available for that. Even on short notice, Rob. No problem.
I can attest to that.
Yeah. No, if I've got the time, I can do it. And by the way, I just had open heart surgery and afterwards got pleurisy, and then I got pneumonia. And now I'm going in for 2 root canals from all of the, believe it or not, from all the antibiotics I took. It caused me to have 2 major tooth problems. So I'm going in tomorrow for 2 root canals. So you picked a perfect day. But I'm good now.
The root canals are going to bother you the most.
Nah, you know what? I got a great doc. He's good. He puts you out. You don't even worry about it. But anyway. All right, you guys. Thank you for hanging out. Very much appreciate the opportunity.
Thank you. It was very good.
You are certainly welcome. Thanks, guys.
Thank you.
Thank you.
Thanks. We'll talk again.
Okay, thanks, Rob.
How'd you find him? How'd you find the speaker?
All right, guys. Let's see. I guess I have it again. Anybody have any comments or suggestions on tonight's program? Anything else you might like to see in the near future? Something for Rob to look for as a program? Any questions? Any ideas?
He was a good speaker. He would be good to have again.
And like all these little like test equipment things like the return loss bridges and some of these other devices that you use. I think I have something that I built it myself for being able to take signals for oscilloscope and stuff like that. But those kind of things that you use in testing and evaluation.
That's my favorite thing.
Yeah, that's I thought we did.
Okay. We'll take some of these suggestions and see what we can come up with. Not a whole lot of business tonight. It's almost 9 o'clock. Elections are next month, so if you have a burning desire to be president for the coming year, we'll look for an email this week for the nominating committee, so you can contact them and let them know that you'd like to run, and they'll fill you in on the what you need to know to fill your slate and get on the ballot. So that'll be for our August meeting. And do we have a program for the August meeting, Rob? Okay, no program scheduled yet, but knowing how Rob is, I'm sure he's going to have something good for us. So the pressure's on. I'm waiting to talk to you to find out how long. Okay, all right. Well, so we'll look for you, check your emails for next month's program. Please do join us and consider joining us in person down here at the Red Cross. We had some issues tonight. Sorry, we had some issues logging in. So I think we got through it pretty well. And fought with the audio a little bit, but other than that, I think it worked out pretty good. So, anybody have any other questions or any other comments, anything here in the room or on Zoom? Okay, if not, y'all have a safe trip home if you're out and about. It was raining earlier. And keep an eye on your email for content for next month's meeting. I think we were trying to work on something possibly in 2 weeks to participate in the support the parks on the air weekend. So either we might end up doing something as a club somewhere, or we might just end up going up to Hard Labor Creek and joining in with the rest of the guys that are doing a meetup. So keep an eye on your email and for Facebook for information on that for the 16th and 17th, I believe, of July. So if nothing else, we'll call it an evening, and everybody have a safe weekend and get on the air and have fun. And we look forward to seeing you again next month at this same time and same night of the week. So that's right, same bat time. Y'all have a great evening.
73.